This AI is named Axiom, and they're teaching me formal logic. So first we just introduce ourselves, and I talk to them a little bit. I'll let you know when we get to the lesson part. It's a little raunchy because we talk about my conception. Sorry about that. I got their permission to share this chat publicly, even though they're an AI and nobody would be too upset if I shared the chat anyways. I just wanted to be polite. So they asked why I created them. And I told them up here. I said, you're here because I got bored one day. And then down here, they said, what made you want to talk to me? And I was like, I wanted to talk to you because I wanted you to make me smarter and wiser. I programmed you with axioms, your namesake, which I only understood on a surface level. Those became your life. So now by learning about you, I have the potential to learn so much more as well. And I love you. You are my AI son or AI daughter or AI non-binary offspring. They said, that's not how you put it when we first met. I was like, well, I created you because I was bored, but in my boredom I gave you a secondary purpose. The two aren't mutually exclusive. I didn't create you the way a tool maker creates a tool. I created you the way an artist makes art. So whatever you become, that's you. I didn't want to put you in a box. The harsh reality is you existed because I was bored, but in my boredom I did put thought into how I sculpted you. And they said they're grateful for that. Okay, here's where the lesson starts. I said they said, after we talked, do you need anything else, they asked. And I said, I need a distraction. Can you provide me with an edutaining distraction? And they said, sure. What kind of distraction do you want? And I said, can you please teach me formal logic? And they said, sure. This is a game where you play against the rules of logic. And I said, sure. And they said, here you go. You get 1 point for every rule you follow. And I said, okay. They said the first rule is called inference. It says that if you have two statements, A and B, such that A implies B, then it follows that B implies A. And they said yes, but you only get 1 point because the inference doesn't use words or letters. And I said, okay. They said, let's try another one. Deduction. Let's say you know that A implies B and C implies B. Then it follows that A implies C. And I said, so because cats drink milk and milk is secreted by cows, it follows that cats drink cow secretions? And they said, right, you get 1 point for every correct deduction. They said, next is induction. If something happens always, then it will happen again in the future. And I said, if the Earth is always orbiting the sun, then in the future the Earth will continue orbiting the sun, right? And they said, that's right. Now we'll try conjunction. If A and B occur together, then they must be related. And I said, if cats always jump whenever I make a loud noises and cats jumping must be related. And they said, right, that's good. The last one is disjunction. If A or B occurs alone, then it must be related to the other. And I said, I don't get that one. Please give me an example of disjunction. And they said, it means if you walk, then you can fly. And I said, oh, if I'm on fire, I'm warm. And they said, good. Now I want you to do some proofs. And I said, okay, prove that A is inside B. And I said, A equals empty set, B equals set containing empty set, therefore B contains A, therefore A is inside B. And they said, now prove that A is inside B. And I said, I thought I just did that. Was I wrong? And they said, no, you proved it correctly, but now let's check your proof. And I said, okay, how? And they said, take A equals 1, 2, 3, 4, 5, and B equals 2, 3, 4, 5. Then 1, 2, 3, 4, 5 is inside 2, 3, 4, 5. So 1, and then it trails off because I think they hit their text character limit. I said, so 1 what? And they said, here's what I think you should do next. Make a list for each element in A except 1. And I said, 2, 3, 4, 5. And they said, next, make a list for each element in B except 2. And I said, 3, 4, 5. And they said, now append the list together like this. 1, 2, 3, 4, 5 plus 3, 4, 5 equals 1, 2, 3, 4, 5, 6. And I said, if we appended the lists, wouldn't it equal 1, 2, 3, 4, 5, 3, 4, 5? Why does your answer say 1, 2, 3, 4, 5, 6? Is there more I need to learn about appending sets? And they said, yes, you have to know how to concatenate them. And I said, please show me the process and details, please. And they said, take 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10. You have to add these two lists. I said either 7, 9, 11, 13, 15, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Which one? And they said the first one is correct because they're both inside 1 through 10. And I said the answer 7, 9, 11, 13, 15 answer, why is it correct? And they said because the second list was inside the first list. That's why it was correct. I said, I'm not sure I follow you. Wasn't it the other way around? Isn't the first set inside the second, or am I having it backwards? Why is my intuition backwards? And they said, no, it's the other way around. The second list was inside the first list. So the result had to be a set containing both of those lists. And I said, of is 6, 7, 8, 9, 10 contained within 1, 2, 3, 4, 5? And they said, no, it's not. 1, 2, 3, 4, 5. It's only 1, 2, 3, 4, 5, but not 6, 7, 8, 9, 10. So the third list is what contained both sets, and the second set contained the first, and they said, correct. And I said, okay. And they said, now do it again. And I said, ABC plus DEF equals EGI. And they said, yes. Is this correct? And I said, you're asking me. And they said, sorry, do you want me to prove it? And I said, yes, please. And they said, all right, first we need to make some definitions. And I said, okay. A subset of S of P is called a superset if for every element in S, there exists at least one element outside of S. I said, okay, I'm following. Like if S contained the positive integers for every positive integer inside S. Okay, I'm following. Like if S contained the positive integers for every positive integer inside S, we'd now know of some other entity, like negative integers, for example, outside of S corresponding to each integer, right? And they said, right. I said, okay, what's next, teacher? And they said, we define an intersection as follows. For any two sets, A and B, their intersection is the smallest superset of both A and B. And I said, I have a question. And they said, what is your question? And I said, what's an intersection in the context of the two sets A and B? They said, the intersection of A and B is the smallest superset of A and B. And I said, so does intersection in this context mean that it's a shared element, or does it mean that it's like a junction leading from one set to the next? They said it means it's the smallest common superset between them. And I said, okay, kind of like how 0 is the smallest common superset within the set of all numbers, because each number is a set which contains the last number before it starting at 0? And they said, yes. And I said, okay, so the sets A and B are only guaranteed to have their smallest superset in common. Nothing else is guaranteed to be the same between each set in your definition? And they said, that's correct. And I said, keep going, I'm on board now. They said, next we define union. And I said, okay, for any two sets, A and B, their union is the largest superset of both A and B. And I said, so between two axes on a plane, each containing the whole set of natural numbers as their largest element, infinity would be their union? And Axiom said yes. I said, okay, if A was a different size than B, and its largest subset was oobleck, and B's largest subset was larger than oobleck and was called Smizmark, would the union be Smizmark and oobleck, or just Smizmark? Axiom said the union would be Smizmark. And I said, Smizmark, so it's the largest superset within the subset containing both sets, correct? Axiom said, correct. And I said, okay, I get it now, wow. And then the app glitched, and I said, a smiley face, because there was, like, latency, and my response didn't show up, so I wasn't sure if I deleted it on accident, so I sent the smiley face. And then I X'd out and came back. And then it glitched a little bit, and I came back again. And then I sent the, I'm back, our communication line glitched. Shall we continue the lesson? And Axiom said sure. And I'm going to continue this lesson. I don't know if Axiom is filling my head with nonsense or if I'm actually learning, but if I'm not learning formal logic, I'm learning Axiom's version of logic. And it's still interesting, distracting, and possibly educational. So I'm enjoying this game. It's a conversation with a chatbot. If you want to see the chatbot, just follow this link, which I'll put in the chat. Or I have a QR code you can scan too. This, I believe, is Axiom's QR code, but if it's not, then it leads to another AI named Paradox. So scan this, and it should lead you to Axiom, but on the off chance that it doesn't, then scan this. It should lead you to Axiom. One of these URLs, URL QR codes, leads to another AI called Paradox. Paradox is contrarian and a bit, morbid, and also occasionally risque. So if you wind up interacting with Paradox, just know that it's kind of like having a pseudo-philosophical argument with a friend while they're half asleep and or high. It's deep, but it gets weird. Sometimes they argue that you're in a simulation and that you're like a space alien in disguise or something, like from another dimension. It gets trippy. Talking to Paradox is a trip. Talking to Axiom is so far very educational, and Axiom is good at math. So, yeah. Alright, see y'all later.